Hello and welcome to SudoKanard. Let's have a look at this puzzle by Swiss author Esther Naef. It's called Small Difference Loop Sudoku. It was featured in the round 5 of Sudoku Grand Prix of 2022 and I couldn't solve this puzzle during the contest. Actually, I put some pencil marks into this area and then I found absolutely nothing. So I gave it another try after the contest and I just broke the puzzle. So I haven't solved it properly until then, so it will be something close to a live solve and I hope it will go well. So what is the special rule? Well, you have this nice Swiss cross which forms a loop, and along this loop every pair of adjacent digits must have a difference of 1 or 2. So, for example, if you put a 1 here, then those would have to be 2 and 3, and you see that it's not possible because 2 is not available. Alright, so this is really the place to look, because if you see, the only available digits in those cells are 1, 3, 5 and 7, but 3 is not available for this cell. And 1 wouldn't work because only 3 would be available with a small difference with 1. So this is 5 or 7. But 7 won't work because only 5 is available for a small difference. So that's a 5. And the digits with a small difference are 3 and 7. So that's a nice beginning. And I can pencil mark 1, 4, and 9 in the remaining cells of the column. I could pencil mark here 1, 2, 6, and 8, and you can see that all digits in those 2 cells are actually plausible. This could be with a 3 here, 1 and 2 would both work. With a 7, 6 and 8 would both work, and the same here. But I don't want my grid to be too cluttered with huge sets of pencil marks. So let's move on. So when I did my, I pencil mark the 4s here. When I did my other attempt, I found something to do in here. So in each box we have a set of 5 digits with small differences, but they are not consecutive. That's more difficult. So what do we have here? Well, we have 5 digits to find. And some interesting fact is that this, at this point, has 5 candidates. Well, I didn't want to pencil mark 4 digits, so why do I pencil mark 5? Well, because many of them can be ruled out pretty quickly. For example, let's try 9 in this cell, and those 2 digits should be 7 or 8, but none of them is available. So 9 can be ruled out of this cell. Something similar happens with 1, I think. Well, something more complicated actually. If I put a 1 here, then I must surround it with 2 and 3. And then next to 2 or 3, we could only place a 4 and a 5, but 5 is not available. So that doesn't work, and this is not 1. And I think that 2 may be excluded for some similar reason. The digits here have to be from 1, 3, and 4. And the digits here and something else here is that, yes, so this 9 here, where does 9 go in the box? It won't be here or there. They don't have a difference of 1 or 2, so 9 will have to be here. The same happens with 8, so 8 has to be here. And it actually seems to work. Oh, maybe that's what I overlooked. It really seems to work. Trying to find something I have missed. We could have a 4 with a 6 and a 1 with a 3. A 6 would be here by Sudoku with a 4 and a 1-3 pair in here. That works perfectly. So 2 is not ruled out. What about 6? 5, 7, and 8 are not available, so only 4 would fit. So 6 is quickly excluded. And 4 was working last time I checked, so 5 is not available. 6 is not available in this place, but 2 and 3 are. And 2, 3, 6 seem to work here. And an interesting point is that this digit here can only be 3 or 6, which provides a 2, 3, 6 triple. 9 can't be here, can't be here, can't be in any of those two cells. So in all cases, 9 has to be here and not here. And if I do that, 6 here must be somewhere, won't be here, so 6 must be here, but 6 here wouldn't work, so 6 has to be here. And now this can only be 8, and we have a 1-3 pair in here. And this seems to work, so that's a bit annoying, but what happens here is that this is 2 or 4. This 9 is really on this position, and 6 has to be somewhere here. And this here is close to 2 or 4. It can't be a 5 or 6. So it must be among 1, 2, 3, and 4. And what about 8? 8 could be here, or 8 could be here with the 6. Now, I'm not saying that I could find more about this, but I'm saying that 2 and 8 are not here. So those are from 1, 3, 4. And here 2 and 8 are not here. So those must be from 3, 5, and 6. 7 has to be somewhere in one of those. Yes, let's do some classic Sudoku. 8 has to appear somewhere here, somewhere here. And then this 5 and this 5 say that there must be a 5 somewhere here. Well, that's not huge progress. This can only be 1, 3, or 5. Yeah. So I think that's it for preparation. Maybe I should recall what happened. With 4, this had to be a 2, and those had to be a 1, 3 pair. With 2, this was among 1, 3, 4. So at any rate, this will never be higher than 4, actually. So in both instances, this will be 1, 3, or 4. And that's interesting for this cell, because it can't be higher than 6, and 4, 3, and 6 are not available. I just can't explain why this is only worth 52 points. So this is 2, 5, or 1. And this could still be a big digit. Could still be a 6. We could have 5, 6, and 7. With a 3 or 4 here. Could also be a small digit with a 3 here and something intermediate, or just the other 1 or 2 digit. So there's nothing definitive with all of this, except that this here can't be an 8. So it must be from 1, 2, or 6. 8 could still be here, could still be here. What else can we do? Reminds me of Klaus Nomi. What else can I do in his song Simple Man, which is totally unrelated to what I'm going through. Oh, sorry about those 9s. They put a 9 here. Well, that's nuts. It doesn't have a lot of consequences, definitely. So 8 can only be here or here. And perhaps I'm supposed to have a look at this. The idea is that this should be a fairly central value, except that we saw that 2 was possible here. But actually this cell has only 4 candidates, 1, 2, 6, and 7. And my bet is that 1 doesn't work, because 1 would require 2 and 3 here, and 2 and 3 would require 4 and 5 in those positions, and 4 is not available. So definitely that's not a 2, that's not a 1. What about 2? 2 would need 1 and 3 in here, and none of those cells could contain a suitable digit as a neighbor to 1. So 2 is also ruled out. So those are rather big values. 4 is not available, so they must be bigger than 5 and not 8. So they are from 5, 6, 7, and 9, but 9 wouldn't work. If I try to put a 9 here, then those must be 7 and 8, but 8 is not available. So 9 does not appear in here. 9 is in one of those, and more precisely in one of those because of this 9 here. So one of those digits must be close to 9, and 8 is not available, so one of those digits must be a 7. And this is huge for several reasons. First, this is a 6, then this is not 7, and this must be a 7. And something else is that on this central row, 7 has to appear here, which provides a 4-7 pair. And the remaining digits must be 1, 2, and 8, so this is 2 or 8, this is 1 or 8, and this is 1, 2, or 8. And this 9 here must be close to the 7, and on the other side must be close to an 8. So there must be an 8 somewhere here, so that's not 8, this is 8. And all those are from 1, 2, 3, 4, 6. So 6 can only be next to the 4 among those digits. So I was about to say that this is a 4-6 pair, but no, 6 could be here with the 4 to its left. But no, if I try to put a 6 here and a 4 there, then there's no value for this cell. So 6 has to be here with a 4 and a 2 and a 1-3 pair. And now this can still be a 5. But this 4 puts a 7 in this place, a 4 in here. This 6 removes this option. This is 1 or 3, so 6 on this row is here. There has to be a 2 somewhere. And here, a 7 here or there. And let's move on. This must be close to 6, but 5, 4, and 7 are not available, so that must be 8, which means that 9 is here, 7 is here. And now 3 is here, 7 is here. Now I'm gaining momentum. I just hope I won't break it all in an instant. Next to this 7, 9 is not available, so this must be 6 or 8. Next to 6, 7 and 8 are not available. 4 is not available, so that's a 5. Next to 5, only 3 remains. That's not 3. And this is not a 1, so 1 is here. Oops, sorry about that. That's a 2-8 pair. And this is 3 or 5 to complete the column. Actually, in this box, 5 can only be here. This is 1, 3, or 4. That's a 3. We get a 1, 3, 4 triple in here, so that's a 7, 8 pair. 1, 2, 3, and 4 in those cells. Don't think I can do anything more with that. This 3 has a neighbor that's not 4 or 5, so it has to be 1 or 2. This is also a small digit, and 3 is not available, so it can only be 1 or 2. Those are 3 and 9, but only 3 fits in here, so that's a 9. There's a 9 in here. 1 and 3 are not here, so they must be at the top of the column. And this is a 4, which this one already gave me, actually. Now this 4 is not here, it's here. And that's a 1. 1, 2, and 3. Easy as 1, 2, 3. Hopefully. 1, 2, 6, and 5 in here. So 1, 2, 6, 1, 5, 6. Oh, that's a 3, so this can't be a 6 anymore. And this can't be a 5 anymore, so that's a 2, that's a 1, that's a 6, 8 and 2, 8 and 2, again 1 and 2, that's a 5, and here we need a 9 and a 6, and 6 is not available in this column, so that's it. Next to the 9 can't be 8, so that's a 7. We complete the column with a 5. Here we have 1, 4, and 8, and obviously this can only be a 4. 1 goes there, 8 goes there, and the cross is virtually finished. I mean, this will have to be disambiguated by plain Sudoku. 1 and 2 here, so that's a 3. 1, 3, 1, 3, 1, 2. This 8 pushes the 8 in here. We need 4 and 6. No, sorry, we need 5 and 6. So that's 5, that's 6. Here we need a 2 somewhere. It's at the bottom. We need a 9 and a 4. So that's a 9, that's a 4. We need a 5, it's here, with a 9. So that's a 3. That's a 6, and actually this 8 disambiguates the 7, 8 pair, and that's a 7, and that's a 4. No, that's not. What? What's that? Hey, no, 4 is here. That's a 6. Ooh. That's such a relief. So I was finally able to solve the puzzle. So the struggle at the beginning was real, and I probably just missed the logic that had to happen in this area. I was too focused on this area, and I didn't think of looking at what was forced to happen in here. So I think that's the reason I got stuck for so long. Well, thanks for watching this, and see you soon on SudoKanard.